Hi dear students, this is Sanal from Healbodhi classes. Welcome back to AS level CAE Physics 9702 series. So from the previous lectures, we have already learned that about the systematic error and random error, right? Systematic error is a fixed error. Random error is variable error. So how can you minimize the random error? In this session, we are going to learn the uncertainties, okay? How you can calculate the uncertainties in the measurement. Now we will check what is absolute uncertainty and uncertainty, what exactly it is. If I'm asking you to measure the length of a pencil, what you will do, you will take a scale and you will start measuring it, right? Suppose a scale is there. Okay, this is a scale and you need to measure the length of a pencil. So the scale will have the divisions, right? The 0 will start from here. 1, 2. Say this is 10 centimeter and this is 11 centimeter. Each centimeter is divided into 10 equal parts. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, 10 equal parts. So what you will do, one end you will coincide with the 0. Then suppose the other end is coinciding here. 1, 2, say 3. Okay, this is the measurement. Okay, so this is 3 and 4. If you zoom in, so it is between 3 and 4 division, right? So that is the uncertainty in the measurement between 3 and 4. 1 mm between 10.3 and 10.4. What is the exact value? That you can't say, right? The uncertainty lies there in the measurement. So what you will do? So you know that 10.3 is the minimum value, right? A maximum it can go up to 10.4. So the uncertainty of the measurement lies between 10.3 centimeter and 10.4 centimeter. Is it clear? So absolute uncertainty means this is the maximum possible error, maximum possible uncertainty in the measurement. Okay. So what is absolute uncertainty? Absolute uncertainty is approximately equal to range over 2. Range over 2. You need to remember this. Okay. Range means that what maximum value minus minimum measurement upon 2. So in this case, what is the maximum? 10.4 minus 10.3 divided by 2, which is equal to 0.5, right? It can be plus or minus 0.5. So how can you represent this length? So it will be 10.3 centimeter plus or minus 0.5 centimeter. So that will be the length. Okay, this is how you represent. In this case, you assume that one end is exactly coinciding with the 0. Okay, you didn't calculate the absolute uncertainty in that end. Suppose if you are starting the measurement from 1 centimeter, then this uncertainty will be there also, right? So if both ends you are calculating, total absolute uncertainty will be equal to 0.5 plus 0.5 on both. One and 0.5 absolute uncertainty is there, right? So it will become 0.1 centimeter. Understood? So is it clear? This is for one single measurement, right? So what is the procedure to minimize the random error? To minimize the random error, you need to take multiple readings and take the average of it, right? So we will check if you are getting a multiple readings, say 5 readings or 6 readings, and different values you are getting, how you are calculating the uncertainty and absolute uncertainty in a given set of measurements. Okay, so we will learn that with another example. Say a length of a road is measured and the values for 6 readings, 6 measurements. You consider this example to find out the absolute uncertainty and uncertainty in a given set of measurements. Okay, so the length of the road is measured and the values, the measurements are, you take it as first measurement 5.4 centimeter, second one 5.3 centimeter, third one 5.2 centimeter, 5.4 centimeter, 5.1 centimeter, and another measurement 5.3 centimeter. So these are the measured values when you took a 1, 2, 3, 4, 5, 6 measurements. Okay, so how will you find out the absolute uncertainty and the percentage uncertainty? With this one example, I will explain all the process and you can remember and understand it. Okay, so first step is you need to find out the average value of this one, right? That is the average value of the measurement. So average value or mean value of the measurement. So let's say length you are measuring, I am taking L as a simple and the average value bar. Okay, so how can you find out this one? You will add everything and divide it with the total number of readings, you will get the average value. Okay, so when you add all these things in your calculator, you will get 31.7 upon 6 readings are there. This will be equal to 5.28. You can take it as 5.3 centimeter. So this is the average value of the measurement. Understood? Now next step is you need to find out how much each measurement is deviated from the mean value. So that is absolute uncertainty in each measurement. Okay, so absolute uncertainty in first reading. You take it as delta L in 1. Okay, so delta L, the absolute uncertainty in the first reading will be the difference between the mean value of the measurement and that reading. So mean value minus L1, right? Which is equal to, what is mean value? 5.3 minus what is L1? 5.4, which is equal to minus 0.1. Delta L2, which is equal to average value minus that reading, second reading. So 5.3 minus 5.3, which is equal to 0. So delta L3 is equal to average value minus the third reading, which is equal to 5.3 minus 5.2, which is 0.1 again. Delta L4, which is equal to average value minus L3. Average value minus L4. Fourth reading, so 5.3 minus fourth reading is 5.4, which is equal to minus 0.1. Delta L5, which is equal to average value minus the fifth reading, 5.3 minus 5.1, which is equal to plus 0.2. Absolute uncertainty in the sixth reading, average value minus sixth measurement, what is that? 5.3 minus 5.2, which is equal to plus 0.1. So you got the absolute uncertainty in each measurement. Now you need to take the average of this absolute uncertainty. So average of absolute uncertainties. How can you take the average? And when you take the average, you need to ignore the sign. Okay, you cannot neglect the uncertainty. Uncertainty should always get added up. Okay, so you need to add the magnitude of all these value. What is the 0.1 plus 0 plus 0.1 plus 0.1 plus 0.2 plus 0.1 divided by total set of readings 6. So what is the answer? 0.1. Okay, this is the absolute uncertainty in the total measurement. So your final quantity will be, what is the length is equal to, what is the average value? 5.3 centimeter plus or minus 0.1. Okay, so this is the physical quantity, this is the mean value of measurement, and this is absolute uncertainty. You understood this one? The procedure, okay, the method of calculating absolute uncertainty in a given set of measurements. Okay, if you want to check this one, this uncertainty will be approximately equal to, this is the procedure to calculate, approximation is there. So absolute uncertainty, I gave you that, what is that, range by 2. So this is approximate value. If you want to find out the approximate value of absolute uncertainty, what you will do? The range you take and divided by 2. Range is what? Maximum minus minimum divided by 2. Right? What is the maximum value of measurement here in this reading? It will be 5.4. The minimum is 5.1. Right? So 5.4 minus 5.1 divided by 2, so you will get approximately 0.14. So 0.1 you can take. So now you understood what is absolute uncertainty in single measurement. If a set of measurements are given, how to calculate the absolute uncertainty and how to represent that physical quantity. The mean value plus or minus absolute uncertainty. This is how you represent the physical quantity after measurement, right? With uncertainties. Is it clear? Okay. So now, if you take the fraction, say delta L is the absolute uncertainty, right? Divided by the mean value of the measurement. So what is this? This is called fractional uncertainty. Fractional uncertainty is the absolute uncertainty divided by mean value. So like that, the mean value, what is the uncertainty, absolute uncertainty, what is the error in that measurement? It's you're taking the fraction of it. Like your mark, out of 100 you scored 80. So if you want to take how much mark you lost, 20 by 100, right? Similarly, in the mean value of measurement, this much uncertainty is there, that fraction you are taking. Okay, if you multiply this with 100, you will get percentage uncertainty. So you remember with this example, length you are measuring. So delta L is the absolute uncertainty divided by the mean value multiplied by 100. So you will get what? Percentage uncertainty. So now theory part for uncertainty and percentage uncertainty is over. So what we have learned till now? We have learned first, in one single measurement, how will you calculate the absolute uncertainty? What is the uncertainty in that measurement? What is the absolute uncertainty? So absolute uncertainty will be what? Be approximately equal to the range over, range is maximum value of the measurement minus minimum value of the measurement divided by 2. You will get the absolute uncertainty. Next is, if a set of values, set of measurement is given, what you will do? How will you calculate the absolute uncertainty in that measurement? First step, you will find out the average mean value of that physical quantity. Next step, what happened? How much each of the readings are deviated from the mean value? That is the absolute uncertainty in each readings. Then what you will take? You will take the average of that absolute uncertainty. Okay, you can represent that physical quantity with the mean value measurement of the measurements plus absolute uncertainty. So if you are taking the fraction means out of that mean value, this much is the absolute uncertainty, correct? So like your mark, you can remember that out of 100 you scored 80 means you lost 20. So if you are taking 20 by 10, that is the fractional loss of your mark. Similarly, here out of this average measurement, this much is absolute uncertainty. If you multiply by 100, what you will get? The percentage uncertainty in the measurement. Like 20 by 100 into 100, what is that? 20% of mark you lost. You scored 80%, 20% loss. Similarly, here percentage uncertainty means what? The absolute uncertainty divided by the mean value multiplied by 100. I hope this is clear to you now. Okay, now this is the measurement, right? Next, one type of error propagation is there, or uncertainty will propagate if you use this measured value to calculate some values. For example, you have an equation. Speed is equal to distance by time, right? If you have an equation, that is called error or uncertainty propagation. So if you consider some uncertainty delta S is there in the distance measurement, and delta T is the uncertainty in the time measurement. Okay, so what happens is, if you want to find out the percentage uncertainty in the speed, okay, so I'm taking this as V. Percentage uncertainty, how will you calculate? The absolute uncertainty in the velocity upon the average value multiplied by 100 equal to, which all measurements you have used? Distance, right? So what is the absolute uncertainty in the distance? Distance upon the mean value of distance plus delta T upon T. Okay, both multiplied by 100, you will get the percentage uncertainty. Understood? Is it clear? So that means this error or uncertainty happened in the measurement of distance, and the uncertainty happened in the measurement of time. Both are propagating while you are using both measurements to calculate the velocity, right? Understood? Then finally you can represent the velocity as V average or mean plus or minus delta V. From this equation you can easily find out delta V. In that equation, okay, in that equation the power is always multiplied with the uncertainty. For example, delta S, what is the power? Distance by time, power is 1, right? You are actually multiplying 1 here also, 1 here also. Another example, if you are finding out the volume of a cube, what is volume equation? V is equal to L cube, right? So you are measuring the length, L is represented, L is equal to L plus or minus delta L. Okay, with uncertainty they have given. Understood? So this uncertainty will propagate in this equation. How it will propagate? When you write the percentage uncertainty for V, volume, so delta V upon V into 100. So this will be what? Percentage uncertainty in calculating volume. Okay, this will be equal to L cube. L, what is the percentage uncertainty? Delta L upon L into 100. Always multiply the power. What is the power here? L cube. It will be 3 times this. Understood? The power is always there. This equation also, distance the power is 1, time the power is 1. You are multiplying it. Usually 1 we don't write. If it is square, it will be multiplied with 2, like that. The root is there, it will be multiplied with 1 by 2. Is it clear? So we finished the uncertainty calculation theory part. Okay, just a quick recap. We have studied how the uncertainty is calculated in single measurement, right? Using an instrument. First one. Absolute uncertainty is the range by 2. It is approximately equal to range over 2. And the range is the maximum value of the measurement and the minimum value of the measurement. Divided by 2, you will get approximate value for absolute uncertainty. The error or uncertainty lies between the least value, minimum value it can measure, right? From the first example, 1 mm is the minimum value. The error lies between those two, 10.3 and 10.4, right? Between these two values, the error is there or uncertainty is there. Then after that, if you are getting a set of readings, a set of measurements, how will you calculate that? First, you will get the average value of the physical quantity. Then you will check how much each reading, each measurement is deviated from that mean value. You will take the difference. So that will give the absolute uncertainty in each measurement. Then you will take the average of it. Then you can represent that quantity average value plus or minus absolute uncertainty. Then if you take the fraction, so how much is the absolute uncertainty in the average value? That will give you the fractional uncertainty. If you multiply with 100, what you will get? Percentage uncertainty in the measurement. Okay, this is in the measurement. If you use this measured value to calculate a physical quantity using an equation, what happens? This error will propagate in that calculation. How it will propagate? So each and every absolute uncertainty you need to add. If you are finding out the percentage uncertainty you need to add. Right? When you add, you need to check that each uncertainty is multiplied with its power. Okay, if power is there, L cube example you take, 3 you will multiply. Your distance by time, distance power is 1 multiplied by fractional uncertainty delta S by S plus 1 multiplied by fractional uncertainty in time delta T by T multiplied by 100, you will get the percentage uncertainty. So this is the theory concept about the uncertainties and how you calculate it. So we will have some practice session in the next video. Next video I will take 5 questions, structured questions and 5 MCQs, and we will practice those questions. See you in the next video. This is Sanal from Hilbodhi Classes. Bye.